Good morning, everyone. Welcome again in this physics class of torque on a current loop. Firstly, we will discuss syllabus. Syllabus is torque experienced by a current loop in a uniform magnetic field, moving coil galvanometer, its sensitivity, conversion of galvanometer into an ammeter and voltmeter. But very important part is torque. What is torque? Children, what is torque? Very important part. Torque. What is torque on a current loop in uniform magnetic field? So then first I will discuss torque. What is torque? The turning effect of the body about an axis is due to the moment of force or torque applied on the body. It is called as the torque. Another meaning of torque, the moment of force or torque is equal to the product of magnitude of the force and the perpendicular distance of the line of action of force from the axis of rotation. Children, listen, see figure. This is figure. O is the pivoted point. P is another point. F is force, A is another point, and rotation is anti-clockwise direction. Consider a body which is pivoted at a point O. If a force F is applied horizontally on the body with the line of action in the direction AP as shown in this figure, the force is unable to produce linear motion of the body in its direction because the body is not free to move, but this force turns or rotates the body about the vertical axis passing through the point O in the direction shown by the arrow in this figure. Okay, F is the force and OP is the distance, perpendicular distance between them, right? What is the factor of the torque? Number 1 point. Two factors are given below. Number 1 point, the magnitude of the force applied and the perpendicular distance of the line of action of the force from the axis of rotation. The turning effect of the body depends on the product of both the above stated factors. This product is called the moment of force or torque. Thus, the body rotates due to the moment of force or torque about the pivoted point. In other words, the line of action of force F is shown by the dotted line AP. That is this point OP and AP. AP is that. Okay, children, what is the formula of torque is equal to force into perpendicular distance. Now, I will discuss in this chapter torque on a current loop in uniform magnetic field. A closed current loop placed in a uniform magnetic field experiences a torque. This torque is the basis of the working of galvanometer as well as electric motors. So children, very important point. Okay. Children, let us consider a rectangular wire loop PQRS. It is given in this figure. Carrying a current I as shown in the figure, be suspended in a uniform magnetic field. Magnetic field is the vector quantity because it has direction as well as magnitude. Let the length of the sides of the loop PQRS L is equal to L and QR equal to SP equal to small b. Listen children, B vector represents the magnetic field and PQRS the rectangular wire. It is the rectangular wire. In this wire, current is moving in along anti-clockwise direction. Children, Children, each side of each side of the rectangular current loop experience a force in the magnetic field given below by the formula F vector equal to IL vector cross B vector. The vertical sides PQ and RS, children, PQ and RS, it is the F1 force and F2 force, and along the QR and PS, that is the F3 force and F4 force. Okay, see the figure. By the right hand palm rule, here, open the right hand and place it so that tips of the fingers point in the direction of the field, that is, it is the magnetic field, and thumb in the direction of velocity v vector of the positive charge. Then the palm face towards the force and thumb represent the current. Thumb represent current and palm represent force. Okay? Okay, children, listen. See this figure. According to this figure, stretch the thumb and the first two fingers of the left hand mutually perpendicular to each other. If the forefinger points in the direction of the magnetic field, central finger in the direction of the current. Central finger is the direction of the current. And thumb represents force. And thumb represents force. And next finger will represent the magnetic field. Okay, children? Children, by right hand palm rule number 2 or Fleming left hand rule. F1 vector and F2 vector are perpendicular to the page directed away from the reader and towards the reader respectively. The equal parallel and opposite forces F1 vector and F2 vector have different line of action. They form a deflecting couple which tends to rotate the loop clockwise. Children, the up-down view of the rectangular loop is shown in the figure 1b. Children, dot and cross product is represent the field. The current elements PQ current up and RS current down are shown a vector, that is dot or cross vector respectively. Dot and cross represent the magnetic field. The force F1 vector and F2 vector them also shown. Children, listen in this figure. Children, F1 vector represent upward direction and F2 vector represent downward direction. It is the cross product, it is the dot product. Okay? Direction of force F2 is downward and direction of F1 force is upward. According to resolution of vector, then we know that by the help of resolution of vector, children, it is theta